Hey, my name is Ryder, and this presentation is called How to Keep Your Startup's Cloud Secure When Your Security Team is Just You. So first and foremost, you can't. Realistically, one person working on it isn't enough to keep your startup's cloud completely secure. But there are a couple things that we can do in order to make sure that we have the best possible security as we can do it. So we'll do our best. In this presentation, I'm just going to do a quick about me, who this is for, the concept of DevOps engineering and DevOps as a job, your startup security landscape, so application security, infrastructure security, and other, as well as some best practices that I found, and then concluding it all. So let's jump right into it. My name is Ryder Damen. I am a developer advocate at Indeni Cloudrail. And before that, I was a DevOps engineer for a number of different startups. Before that, I was a web developer. And before that, I actually came from a biomedical engineering background. So a bit unusual, but a fun career path for sure. This presentation, who it's for me, essentially. When I was first getting into DevOps, I'm designed the presentation as the things that I wish I knew. So if you're a DevOps engineer and you're not from a security background and you're at a scaling startup, this is the kind of presentation that is for you. No matter who you are, it's important to keep a growth mindset because in DevOps, we're going to be learning new things every day, and I think that's pretty important. So let's first talk about DevOps. This is a list of things that I have been asked to do as a DevOps engineer. Now, a lot of these aren't what you would typically expect from a DevOps professional. For instance, catching an Uber with the company server in the trunk of the Uber. Not necessarily something you would expect of your DevOps team. But what I'm trying to get across here is that it's a lot. So as DevOps engineers, we're going to be asked to do a number of different things. And some of that involves security. Now, you might be from a security background, but I am not. And that's okay. I know to keep my ports closed and I know to limit blast radius, but when it comes to application security or infrastructure security, I am not an expert. I'm an expert at building pipelines. I'm an expert at building infrastructure, but the security part of it, not so much, and that's okay. So let's talk about the security landscape at your startup. First and foremost, I like to split it into three specific categories: application security, infrastructure security, and other. So starting with application security, it's pretty much everything around your application. So making sure your source code is secure, making sure you're free of OWASP top 10 vulnerabilities. Do you have any unsanitized inputs? Are you vulnerable to SQL injection? Cross-site scripting, is that a problem? Also, application composition. So what packages are you bringing into your application? Are you using a Python package that hasn't been updated since 2008? Things like these are quite a problem. And this is what I would consider to be application level security. Also, penetration testing. You've probably got an annual penetration test at your company. And if you don't, I highly encourage that you start one. It can be a difficult sell at first because they'll be anywhere from about $7,000 to $50,000 on the upper end. But really the data that it provides and the things that they find are very, very valuable. So for application security, as a DevOps engineer, you're not really going to have the time to sit down and do your own penetration tests of the application. That's you're not going to have time to do that. Realistically, at a startup that's growing really, really fast, you won't have the time. So what I recommend is implementing tools like these, which are going to be a part of your deployment pipeline and are going to help you identify issues and shift those issues, who has to fix them, over to the developer that created them. So first, GitHub has a number of different tools to help you catch any package security vulnerabilities. And Snyk has that too. I think it's Snyk. It could be Snyk. I'm not really sure. It's like Nginx all over again. So if someone knows, please let me know. But both of those tools, what they're going to do is they're going to allow you to identify any vulnerable packages that you're bringing into your application so that you can fix them right away, even before you deploy them. OWASP-Z or OWASP-ZAP, Z attack proxy, what that's going to do is identify any OWASP top 10 or any issues with your application. So it's web application testing, and that's a great thing to have in your pipeline as well. So for application security, you're going to want to implement the tools into your deployment pipeline. And if you're joining a startup as a DevOps engineer, chances are you're not one of the first hires. So when you get there, there's going to be some legacy code, and there's going to be a ton of technical debt. So when you first turn on these tools, do not be surprised when you see hundreds, sometimes thousands of different things that are raised. That's pretty normal. Incorporate it into your pipeline anyway, but don't fail the pipeline just yet. Don't allow any of these tools to fail your pipeline. Get them in there, get the visibility, start surfacing this to other members of the team that there are problems and that we need to fix them. Set a deadline for when you want this all to be fixed, and on that deadline, fail the pipeline no matter what. So, how do we fix all these issues? We've turned all of this on. How do we fix these issues? You've got to set aside time in your sprint, and I would recommend creating an ad hoc team. So the first thing I like to do is grab the most senior member of the engineering team for half a day, look through all of the issues and triage them. Which ones are actually problems? Which ones are part of services that are no longer even used? Is GitHub reporting on something that we don't even use anymore? Figure those things out. Then figure out how much you think it's going to take in order for just you to fix it, and double that estimation. Maybe it'll take you a week to fix these problems, double it. Because if you've not had familiarity with this, when you go in and you start fixing these issues, you will fix one vulnerability and 5 new more will come up. Or the package that you've just upgraded is no longer compatible with these 4 packages. It's a nightmare. Ideally, you'll want to involve some other engineers, so front-end engineers, back-end engineers, in your ad hoc team for fixing these issues. You don't want to do it just by yourself, but you may have a tough time convincing management to convince these, or to allow these people to work on something that isn't building a new feature. And that's pretty common at a startup, and that's okay. So what I would recommend if you're facing pushback from there is don't try and pull everyone for a full week. Don't try and get the engineering team to focus on it for a full week. See if you can pull people day by day and work on the vulnerabilities that were maybe introduced by them or by someone on their team, something that has to do with that team's context. If it's a day, it's a lot easier of a sell to pair program with them. And then you can fix all the rest of it by yourself. So let's talk about infrastructure security. First of all, are you in a public cloud? If you're at a startup, chances are yes. And then the next question is, are you in one of the big 3? If you're in more of a developer-centric cloud, so a smaller public cloud, it's less difficult to misconfigure things. But as soon as you get into like GCP, AWS, Azure, it becomes very, very easy to create an insecure environment completely by accident. And for this, we would recommend cloud security posture management tools, sometimes abbreviated as CSPM. Now, Cloud Security Posture Management tool, what that's going to do is it's going to scan your public cloud, wherever it may be, and identify any vulnerabilities that are in it. It's going to let you define a policy and show you whether or not your cloud is adhering to that particular policy that you've defined. It's going to report anything that doesn't look exactly how it's supposed to be, so you can go in and you can fix it. So maybe someone accidentally deployed a machine into the wrong subnet. It's going to report things like that. Next is implement infrastructure as code and configuration management. So if you've never worked with infrastructure as code before, I would highly recommend getting involved with it today. I resisted it for quite a bit of time because I was afraid of it. It seemed very overwhelming to get involved with, but I promise you it's easier than you think, and it's a really great thing to get involved with. The infrastructure becomes repeatable, and you're able to define things quite well. I'd recommend using a service like Terraform. Now, the benefit of this is not just repeatable infrastructure and seeing all of your infrastructure as code and version control. It's not that. It's that you can actually incorporate infrastructure vulnerability scanning tools. So whereas a CSPM tool scans your cloud environment and reports any issues, those issues are already in production. An infrastructure vulnerability scanning tool identifies issues before they're going into production. So you're able to catch them before they become actual problems, which makes it a lot easier for you. Consider initial implementation. So how much work is this actually going to take for you to manage? Is it worth the investment of your time? Chances are, yes, it is, but it's not going to be the case for everyone at your particular startup. So a couple cloud security posture management tools are Orca Security, Cloudrail US, or Aqua. And these are tools that are able to scan your cloud environment and report anything that's going wrong in your live cloud. So any misconfigurations, any vulnerabilities, things like that. Some infrastructure-as-code security tools that will catch these things before they go into the cloud, assuming you're using infrastructure-as-code, are TFSec, Cloudrail again, this is kind of our bread and butter, and Checkoff by Bridgecrew. So once again, use a CSPM tool, and if you're using infrastructure-as-code, use an infrastructure-as-code vulnerability scanning tool. Finally, we have other security. So other security is pretty much anything that's not application or infrastructure is how I like to consider it. At a startup, if you've ever had the lovely pleasure of being involved with a SOC 2 audit, you'll be familiar with most of these concepts. So you might not have an IT team, and you might have employees who are using computers, and management might want those computers secure. So are you running an endpoint monitoring service that actually ensures that employees are encrypting their drives, and they have firewalls running and malware services running? Once again, not necessarily something you would expect from your DevOps team, but it's often something that gets handed off to us. So it's important to keep that in mind. Other types of security are other things that would generally be raised in a SOC 2 audit. So does your company have an office? Who has the keys for that office? Is there security? Or sorry, is there Wi-Fi security at the office? Does your company keep a production server on a desktop at the office? These are all important security questions to consider. And for this, I would recommend getting involved with some SOC security tools. So the first one, Collide, is a device endpoint management tool that is my favorite because it's kind of like a Slack application. You put it in Slack, and then whenever someone joins the company and sets up their device for the first time, it will continuously ping them on Slack until they get everything set up properly. So if they're missing a firewall, it'll ping them every day until they finally do it. And that's normally something that's my job, so I quite like that. Vanta and SecureFrame are tools that allow you to manage your SOC 2 audit and your compliance for that. And if you've ever used them, they're super helpful, not just around audit time, but in general. So they'll connect to your cloud providers, and they'll go through and they'll scan much like a CSPM to make sure you have no major vulnerabilities. They're not quite going to do it to the extent as a CSPM tool, but they will raise things like, do you not have any VPC flow logs? Which is something that you'll need in case anything happens. So you'll want to consider those tools. They've also got agents that run on low-level machines that report package vulnerabilities. They're very, very helpful. And when it does come audit time, they allow your auditor to self-service, which is quite helpful. So these are some recommended practices that I have found made my life easier and hopefully will make yours as well. First is bringing infrastructure down to its most simple version. It may be fun to use the latest and greatest, and you know what? It's also good for our careers to use the latest and greatest. It's good to say on your resume that you incorporated this brand new service so that you can get a better job down the line. But it may not be the best for the company. So maybe consider implementing those services in a sandbox environment and reducing your company's production infrastructure to the simplest version. I would recommend doing that, but it's whatever works for you. Next is using managed services wherever possible. So say you're running a containerized workload in AWS, try to consider using AWS ECS Fargate instead of EC2-backed ECS instances. You'll have less servers to manage. It may be a tad bit more expensive, but you won't be responsible for any of the security updates or dealing with any outages or anything. You shift the blame and the responsibility to AWS. And for me, that's worth a couple extra $100 a month. Next is use infrastructure as code, as I mentioned. If you're not using it, get involved with it. It's much easier than you think to use, and it's a great tool. Then recruit other members of your team for feedback. So they may not know what's going on with Terraform files, or they may not understand the the cloud environment as well as you do, but they often have valuable feedback, and the more people you can get involved in the security review process, the better. And finally, shift left, and I don't mean this in the traditional sense, I mean it as shift some of the responsibilities of security onto the other engineers, particularly application security. So it is a full stack engineer's job to ensure that the code that they're writing is free of vulnerabilities and the package that they're bringing in has been updated since 2008. It is your responsibility, though, to ensure that the deployment pipelines you're building are catching these things in case that particular developer forgets this. So shift some of those responsibilities for them, and do that by ensuring that you have checks in your deployment pipeline that fail the pipeline, and don't let that particular engineer deploy until they fix their issues. So in conclusion, simplify everything, use managed services wherever possible, use infrastructure as code, implement application security tools in your pipeline, implement infrastructure security tools in your pipeline, and involve as many other people in the security process as possible. And finally, continuously demonstrate to management that more people in this role is valuable. That's it for me. If you have any questions, you can reach out to me on any of the links below. And I thank you for your time. See you later.